Okay? We're not going to try to skip anything. We're going to go nice and slow. Make sure you see it. Okay, hyperbola. The catch is with a hyperbola, there are two formulas. With the ellipse, you had a plus sign here. And if you have a plus sign there, you can do a plus b or b plus a, and you get the same solution, right? Okay? Problem is, with a minus sign there, it does matter whether it's x minus y or y minus x. It does make them different according to which one's first. All right? Now, the biggest problem that students have is you're so used to the x being first that when the y's first, you'll still use this as x information. And no, that's wrong. This is all y information because it's with the what? Y. But you're just not used to y being first. All right? Minus your x information. Now, for the hyperbola, they will open left or right or up and down. And that's where this comes in. The x ones, x squared minus y squared, will open to the left and they will open to the right. Now, and they'll have the vertexes here, vertex, vertex, and then their foci will be sort of like so. That's how they'll look. They'll have that general pattern to the way they look. You'll have vertex, vertex, foci, foci, but that's because the x is first and x is what? Left and right. Everybody agree x is what? Left and right. Now, for the y squared being first, they will open up and down, and they will have your vertex, and then your focus will be above and below. Now, if you look at these two formulas, you notice I didn't talk about either one of these numbers being big or small because it doesn't matter. All right? There's just going to be a number here, a number here. Doesn't matter which one's larger, which one's smaller. There's just going to be a number here, a number here. All right? What tells you which direction it goes is whether it's x first or y first, not how big these numbers are. Right. Now, we're going to work one that opens up and down. Honestly, last hour I opened one that opened left and right. And then what they can do, if they want to see an example of up and down, they can watch the video that I'm making now with you. And if you want to watch one that opens left and right, you can watch the video I made with them last hour. Because that way we don't have to go real fast to try to get through two examples. All right. Y minus 1 squared over 25 minus x plus 2 squared over 144 equals 1. All right. Key, make sure you realize it is y first. All right? We're going to find the center. The first thing I want you to do when you work one of these is find the center. And what I'll do is I'll put information over there about formulas and all that, but first thing we'll do is find the center. The center is going to be negative 2, comma 1. That's an x value now. There, see, it's got the x with it. So it's negative 2, comma 1. Negative 2, comma 1, and there's the center. You find the center just like you did for the ellipse. Then, one of the things you do want to realize is this you should be thinking of is 5 squared and what? 12 squared. We're going to count 12 in the x directions because the 12 is under the what? X. So we're going to count 12 to the right. It's going to put us at 10, 1. and we're going to count 12 to the left, which is going to put us at negative 14.1. And we'll try to get this a little bit more proportional, make it look nice, not at negative 14.1. Now, you've got the point here, you've got the point here. Then you're going to count up and down the 5. Now, if you're making slashes and you're counting slashes, you won't be able to keep up with what's important, the number values. So we'll go up and down 5. Negative 2, comma 6, and negative 2, comma negative 4. Now, those 4 points are just like they were for the ellipse, but don't draw an ellipse. Okay? That's going to be just like it was for the ellipse, but don't draw an ellipse. Don't draw the ellipse. All right? Now, everybody okay with getting those points just like you did for the ellipse? Don't draw the ellipse. Okay. So, first thing you want to do is you want to find the center. Then you want to find your 4 key points. And then we do something different. What you're going to do is you're going to draw a rectangle. You're going to make a rectangle using these points to mark the sides of the rectangle. In other words, there's a side for the rectangle that goes here, right through that point. Then it goes through, down the side goes through that point. And the side for the bottom of the rectangle here goes right through that point. And then over here there's a side that goes right through that point. Those 4 points are marking the sides of your rectangle. Those 4 points mark the sides of that rectangle. Those 4 points, wow, Mr. Evans, you didn't draw that very straight. Okay. The rectangle will change lengths and widths based on these numbers. Is that fair enough? Okay? Because that's going to change the next step. That's going to change what the next part looks like. You're going to draw a line, another dotted line, and the dotted line is going to start here, and it's going to go through the corner, through the center, and out the other corner of the rectangle. And these 2 lines are important, and they're going to help us, and I'm going to tell you why. There's going to be 2 of them. They go through the corners, which will take them through the center, and they go up. Those 2 lines are so important, they have a name. And I always misspell it, so I'm going to look in the book. These 2 lines are called asymptotes. That's what they're called, asymptotes. Those 2 lines are called asymptotes. They're real important. And they're real handy for later on. You use them in a lot of math because they make math easier down the road. All right. Okay, so we got the center, we got our 4 points, got our asymptotes. Thumbs up, we're good. Thumbs up, we're good. All right. Now here's what makes this easy. We're about to draw the hyperbola. The asymptotes help you draw the hyperbola. Because what it does, please do not come down inside the rectangle. This point right here on the edge, because this is one that goes up and down, it comes out as a curve and it gets closer and closer to the asymptote forever and ever. In other words, it gets very much like just being what? The asymptote. In other words, a point on the asymptote and a point on this curve are almost going to be exactly the what? Same. It helps you later because with the asymptote, you can estimate what the curve looks like. The asymptote helps tell you the shape of the hyperbola. Now, please never go inside the rectangle. It touches that one point. That's your vertex. And of course, it comes down here. And it doesn't go straight over and then straight down. And it gets closer. Please don't do like the students do, where they'll come out here, they'll get close, and then they'll pull away from it. Okay, that's not right. It does what? It gets what? Closer and closer. All right? And then it comes across this way, and it gets closer and closer. All right? It gets closer and closer to the asymptote. It never touches the asymptote, even though when you draw them, sometimes you'll make a little mistake and make it touch. But it just gets what? Infinitely close. Is that a good idea? You've got, hey, and those are your vertexes. You've got your asymptotes, you've got your vertexes. At that point, you need your foci. We'll come back and talk about the asymptotes a little bit more because we've used them for what we need. We've got the shape of the hyperbola. Notice, if you move the width of this or the length of it, it would change the angle of these, right? Is everybody okay with that? Change the shape of the rectangle, length and width. It's going to change the angle of the asymptotes. That's what I'm getting at. The asymptotes are going to tell you if your hyperbola is real narrow or if your hyperbola is real wide. Got that? We're not going to find lattice recti for these. Maybe we should, but we're not. All right. The next thing you need is you need the formula for the distance from the center to the focus. The formula for center to focus is different than it was for the ellipse. It is the square root of whatever the number in the denominator is squared plus whatever the number in the denominator is squared. Everybody make sure you put a plus sign there. This is different than the ellipse. Plus sign. Right there. So, I'll put it right here. Center to foci equals square root of 5 squared plus 12 squared. Please make sure you square them and add them together first, and you work it out, and you get 13. Okay? You do know you can't take the square root of each one of those separately. Everybody here knows that because you didn't get in here otherwise. Okay, 13. You're going to count up 13. So this thing's going to be really way up here. -2, 14. Because you're counting up from the what? Center. 1 plus 13 is what? 14. And you will count way down here. -2, 1 minus 13, -12. And those are your foci. Those are your foci. You're going to count up 13, then you're going to do what? Count down 13. Notice.
Wait, it was 13, we got 14.
Because you start from here. 1 plus 13, right? And what? 1 minus 13. Count everything from the center on that. Okay. That gives you your foci. Looks pretty good. Let's go ahead and mention this. Your major axis is not necessarily the longer axis. The major axis is the one that has the vertex, the center, and the foci on it. It has all the key information on it. So in this case, it would be what? X equals -2. Major axis, x equals -2.
And it's not, you said it's not always the longest one, or?
Yeah, it's not the longest one like it was for an ellipse. For an ellipse, the major axis is always what? The longest. But in this case, the major axis is always the one that has the vertex and the focus and the center on it. Which, notice it's not the longest here. It's not the longest from here up to here, see? Yeah, so that makes it a little bit different. But they're both, the major axis for an ellipse or hyperbola is what has the center and the foci and the vertices on it. Your major axis will always have your center, your foci, and your vertices. I'm saying all this twice. I shouldn't do that. I don't need to do that. Okay, let's talk about the asymptotes. Before I talk about the asymptotes, we got any questions up to this point? Anything bothering you about it up to this point? So far, we're doing real good with it. Moving on. All right, asymptotes. To do the asymptotes, we're going to use the point slope formula because it makes it real easy. We're always just going to use the point slope formula right there. And we're always going to use the center as our point. Use center as point. Okay? Somebody says, well, no, Mr. Evans, you don't have to use the center. You can figure out what this value is, or you can figure out, use the center. Makes it easy. So, we're going to use the center. Go over here. Y minus 1 equals blank, x plus 2. And there's 2 of them, so let's go ahead and write that twice. Okay? 2 of them, write it twice. Okay, Mr. Evans up here bleeding out math. Don't sleep while I'm up here just giving you all this good math information. I'm working hard. All right. Here we go. The slope. When we do slope, I'm going to tell you the easiest way in the world to do slope. It's change in y over change in x. But when we do slope, we are always going to do going to the right. We are always going to make the change in x go to the right. We're never going to go backwards for our x. Okay? And then if you have your change in y is going up, you get a positive slope. Change in y is going down, you get a negative. This only works, though, if you work from what? Left to right. Left to right. Now, the reason I like that is look right here. How far did you count from here over to here? 12. It's that easy. Count from your center over to here, you counted how far? 12. Then how much did you count up right here? Counted up 5. Does everybody know why you counted up 5 there? Because you also counted up what? 5 there. So that means you counted 5 there, you also counted what? 5 there. But you counted up 5 on one of them, but on this one you didn't count up 5, you counted what? Down 5. The key is you always count your x from left to right. The first person that counts back here, you can just throw out everything I just taught you about slope of the line. You got to go what? Left to right. Left to right. Okay? We're going to use the center and count to the right and then up and what? Down. Now, something you might notice. If you will use the center, you will notice a lot of things happen. Look right here. Yeah. Use the center and those work out. And then look at your 5 and your 12. The 12 was how far you counted into what? X directions. And the 5 was how far you counted into what? Y. And one of them was a positive slope, and one of them has a negative slope. So, and if you look in a lot of the textbooks, they'll have little A's and B's and C's, and all of a sudden you look over here and they'll say y minus h, x minus k. Just use the center and work it out. Don't try to memorize all those little formulas for doing it, because you know how to write the equation of a line. And the last step, eccentricity.
Wait, so the asymptotes, that's all you have to write for them?
Again, you don't have to simplify it.
Okay.
It would simplify to slope-intercept form or standard form, but we're just going to stop right here. It's easy to see, and I know you all have finished up and rewrite it. Okay? Right here. Now, let me mention this. If you want to know what the y value was when x equaled 100, you could put the 100 in here, right, and work it out. But you'd have to put 102, you'd have to square it and all that. If you put the 100 in here, wouldn't it be a lot easier to do? That's going to be a very, very good estimate of that. That's what the asymptote does. It gives you an easier formula to put really big numbers in, or really small numbers like a negative 100 or negative 200. And is it exact? But it's what? Real what? Close. And that's the reason we even talk about asymptotes, is later on when you have a really, really complicated problem, if you can find an asymptote that it gets close to, that makes it a lot easier to figure the values. Are they exact? No, but they are what? Really, really close. Is that good? Okay. Eccentricity. I'm going to put it right in here because I need the room. Eccentricity. Center to focus over center to vertex. Same as it was for the other. And what you find out is if you go center to focus here was 13. So eccentricity for this one is 13 over 5. Over 5. The eccentricity will always be bigger than 1 for these. Eccentricity is always larger than 1. So far, so good? Right. Now, I know that you have an assignment due tomorrow night. And someone in this class yesterday helped me out big time and told me about, was that this class that told me that if you look at the assignment down at the bottom, you just hit submit? Y'all know that? How many of y'all have turned assignments in, you know you just hit submit at the bottom? All right, yeah. And if that doesn't work for you, use the inbox. Now, the catch here, and I know I want an hour of your time tomorrow, and I want an hour Friday. And if you didn't give me an hour yesterday, I want my hour from yesterday, right? But I don't expect you to be able to do all the hyperbolas before Monday of next week. It's not going to happen. Okay, right? Okay? But what I do expect you to do is give me an hour tomorrow and an hour Friday. You can give them 2 hours to me on the same day if you want to. It doesn't matter. But you should at least get down, and we want this done. Okay? Did we talk about this assignment the other day? Have I talked to y'all about this assignment in here? Okay. Here's the deal about this assignment. Let me show you how this assignment works. You will turn in 10 pictures of your work. Somebody says, well, if I took really good notes, can that be one of my pictures? It sure can. Oh, I went back and I rewrote my notes so that it would make sense to me. You can take a picture of that. Mr. Evans, there's 2 really hard problems on 1 page. Can I make that 2 separate pictures? Yes, you may. You show me 10 pictures that show me you've been working in here. The only 2 that I'm going to tell you what they have to be is, remember the pictures, remember the ellipse graphs that we did? Remember how I never gave you the key to 3 and 4? You got to put 3 and 4 in there. One picture's got to be of number 3, and one picture's got to be of what? Number 4. if you think about it, you take 8 good pictures, that's 80 points. I hate to talk about points, but we're going to for a second. You take 8 good pictures, that's 80 points, right? And then the 2 ellipses will be what determines the rest of your grade. Now, somebody says, well, Mr. Evans, I went ahead and graphed some of the hyperbolas. Can I put a picture of the hyperbolas on there? Yes, you may. 8 of the pictures that make me know you've been working. And then what happens is when y'all look at the assignment down here, it says submit, and y'all can click on it. It doesn't do that for my edition. All right. Now, let's talk about and everybody's good with that. That's the assignment. It's due by midnight Friday. Folks, if your computer shuts down and fries and you can't figure out anything to do, just inbox me. Folks, we don't need any stress just because something doesn't work in the computer. All right? We'll figure that out. Okay, hyperbola graphic. We'll click on that. This has not been published yet. They'll be published as soon as I put the